Yeah, yeah. Good evening, everyone. Uh, so I will start the session now. So today, welcome to session five on principles of casting and technology, taught by Professor PK Jha from IT Roorkee. So in this week, like week six session, so there was a discussion on different types of castings, and then different types of furnaces, the heating process that we use in casting process. So that was the whole like component of these week sessions. So I will start the session. So before starting, I will give an introduction to these different types of castings. So sand casting is well known. So sand casting is well known. So we have already discussed in the last 5 weeks of courses. So there was so this week's will deal with these special castings. Yeah. So I was discussing that there were different types of casting process. So I will just give an introduction to all these process. Then I will go to the some of the theoretical questions. So this week is mostly the theoretical part. So then I will discuss those theoretical part. Just I will share my screen. Okay. Yeah. Okay. So these are the different types of special casting process. The first the first one is permanent mold casting or gravity die casting. Then pressure die casting, which is also part of permanent mold casting. So we have two types in pressure die casting, that is hot chamber as well as cold chamber, followed by the centrifugal castings, mostly used for symmetric castings. then shell molding, investment casting, and some of the other special casting process. So I will just discuss. I will use professor's slides for that. Just give me a minute. Okay. Okay. So this was so I'm using the professor's slides to just revise the things. Okay. Yeah, everything is perfect. So as I discussed, the first one is the permanent mold casting. So in this, the main advantage is that in sand casting, so every time we used to break the mold, but in this type we use a permanent mold casting made of some metal so that we can reuse the mold any number of time, so many number of times, so that the production rate will be very much higher. So moles are so I will read point by point. So moles are used repeatedly. So since the surface of the sand surface finish in sand casting is not so good, but here we'll get good surface finish, which is because the good surface roughness of the low surface roughness of the mold surface, because it's a better. Then high production rate, since there are so many unwanted things being cancelled, so making again mold, making use of pattern, everything is removed in this case, and even we can automate this process. Then these are used, but the only limitation in this permanent mold casting is that we use for small size castings. So generally it is for 10 kg, below 10 kg casting we can use. Above that it will be difficult in manufacturing, in making the dies and all the things. So basically permanent mold casting is also known as gravity die casting usually, but it can so whatever other casting process that I am going to discuss, they come under permanent mold casting. So basically the steps that are followed in permanent mold casting is, so die opens, die closed or mechanically clamped, so they come closer. So then we introduce this molten metal inside it, then we solidify, then dies will open up the dies, then casting is taken and it was cleaned for the next operation. So dies are nothing but this the replica of the component that we are going to produce here. So basically there will be two, like there will be parting plane. So the other, there will be two uh, dice as well. So they will be in pairs. They will have bends in order to bends. Usually they are provided to provide a path to escape, for escaping the air. Okay. Also they will have ejection mechanisms to eject the uh, solidified component from that. Okay. So you can ask any doubt in between. Then comes the taper will be provided. So these are the extra elements. These are all for also we have done in sand casting things. Okay. So this is regarding the types of dies. So we can make dies, two dies separate, then or we can make hinge die, we can make a hinge in between, so, or we can make resisted die in which we keep the ribs inside, or we can make multi-stage die. So these are the different types of die that we use. So then cores, so this is the same as in sand casting. It can be made either by sand or metal. So if there is any if you want to produce the castings in large number, so we can make the cores with the use of metals. Okay, so these cores can be water cooled, so in order to introduce a solidification, in a control a direction solidification as well. Okay, so the metals that are used in this is aluminum cast samples, aluminum alloys, copper alloys, later zinc alloys, so which are more or less, except copper, the rest are below 600 melting points, like low melting points. Copper ranges around 900, around 1000 degrees Celsius. So if you want to use this for high temperature, we use a refractory coating. So here that is written, the coating, so which is made of sodium silicate or phosphoric acid. So this is the limitation in permanent mold casting, that castings are limited to 10 kgs. So we will not go more than 10 kgs in this permanent mold casting. So now I'll discuss the first one, that is permanent mold casting or the die casting. So in this, the mold is filled with the use of the gravity. So as I discussed, there will be two molds which are clamped together with. So we can say these are the clamping things. Okay. Then we pour the metal. Once it is solidified, we'll remove. So these are the locating pins in order to exactly locate this thing. Then we take out the component and we'll trim out the gating system, and we'll send the casting product for the further option. So that is the gravity die casting. Then comes the pressure die casting. So pressure die casting is, this is little slower, this permanent mold casting, since you are pouring metal manually. But in pressure die casting, we will use pressure to fill the cast. So it is good for mass production. So we'll have very good accuracy and low cost, since we are producing large goods finish and close tolerances, suited for non-ferrous alloys castings or small castings. So one of the advantage of pressure die casting is that thin features we can obtain using pressure. Since we are using pressure, even if there are thin structures, it can be filled with ease. Okay. Then comes to the die casting. So this is pressure die casting. This is only die castings. So we will have to this is more or less. So let me discuss this one, types of die casting machines. So the hot chamber and cold chamber, let me show here. So see the pressure in hot chamber, which is 150 kgs, and in cold chamber it is 300. So in cold chamber it is too high. So now let us see the structure of hot and cold chamber die castings. So the left one is the hot chamber die casting, in which so the plunger, if you see, which is in yellow color, the entire setup is inside the crucible. Okay, but if you see in cold chamber, we are using a ladle. So ladle to pour the metal, then we use the plunger or ram to push the metal into the casting product, if you see here in the right side figure. So that is the main difference between hot and cold chamber chamber die casting process. In hot chamber die casting, so since the name it is hot, the entire setup will be in crucible itself, whereas in cold chamber, the ladle is brought from the distance far away. So now if you see the superheat that is to be provided in right side, that is cold chamber, is high, because you are bringing the casting from somewhere else. But in hot chamber die casting, the superheat is required is less, because there is no the extra time to bring the metal from the furnace to the mold itself. So that is being avoided. And hot chamber die casting we generally use for low melting point alloys, so which will solidify prior to the entering the mold. So that can be avoided in hot chamber. Whereas cold chamber we generally use for a little higher temperatures, higher temperature matters. But everything comes under die casting process, which is suited for non-ferrous alloys mostly, and a little uh, few of the ferrous alloys like grey cast iron with lining inside. Okay, that is the main difference between this hot chamber and hot and cold chamber. So in pressure die casting, so these are the metals that we use. zinc, aluminum, magnesium, copper base, tin base, and lead. So these are the low melting point except copper that we are going to use. Okay, and these are the designs for die castings. So everything more or less same. So these are the advantages. So that we need to see. So the first advantage is the high production rate, as since we are using metal molds instead of sand molds, and also we are using uh, pressure also as well. If you see here, the 300 to 350 castings per hour with hot chamber, that is more than 5 castings per minute, right? In hot chamber, whereas in cold chamber we have only 75 to 150. Then we are getting very close tolerances, that is 0.0075, and then we have very good surface. So these are already I have discussed. So one thing is we can save labor and time, and it is so economical since we are removing so many unwanted steps in this. Okay, we also have disadvantages. One is we cannot use this for bigger castings. The other is if there is air entrapment, we can get the gas porosity inside. We also, this is also costly. The die that is used for this is too costly to make, and may have metal losses as well. Okay, only, but it is limited to only few alloys. So these are the some of the disadvantages in these castings. Okay. Okay, so let me so this is, so this is the like first day of this week. So this is regarding the permanent die casting molds. So let me discuss the second one, uh, that is low pressure die casting. So till now we have seen we are using some pressure forcefully in order to fill the die. So there will be too much of turbulence in the because the velocity of the melt that is going into the casting will be very high. Okay, but in low pressure die casting, so there is a problem of oxide formation because of the turbulence inside. But in low pressure die casting, we use low pressure. Even we go to vacuum as well in order to fill the casting. So we avoid this turbulence that is being created inside it. So this is mainly used for aluminum or magnesium, also for thin sections. Mold is filled upward displacement motion, metal from the sealed melting pot or bath. So I will show the diagram. There is a diagram coming up, so it will clear the any doubt that are having. So these are the specifications. Low pressure eliminates turbulence and air aspirations in it. So this is the main advantages of using this low pressure. Okay, let me show. So this is the diagram of low pressure die casting. See in this figure, so we are using pressure gases inside so that it will push the metal, the molten metal, and this molten metal will travel up and fill the casting. So once it is solidified, we'll remove the moving plate and we'll remove the casting. Okay, that is the high, how we are using low pressure. So we are not forcefully uh, forcing the metal into the metal, but we are using low pressure. Okay, so this is how it works. So there are some other models of this low pressure. Even we can use vacuum die casting. So this is how it works, vacuum die casting. Okay, so left side is what molten metal is there, then we have mold followed by the gate. So the right side is when we push, when we combine these two and we create a vacuum, this metal will enter into the casting. Okay, that is how this vacuum die casting works. So what is the use of this? So any entrapment of gases will be avoided completely, because we are creating a vacuum. Whatever the gases that are present, that will go off. So there will be no turbulence in the metal as well. So that is the two big advantages of using this vacuum or low pressure die castings. So crosswork process is one more similar process that avoids the oxide formation as well. So we use a special electronic magnetic pump. So this is the diagram. So we have initially we pour the metal inside and we'll keep this electromagnetic pump, which will pump everything. There will be no mobile parts in pump. Okay, so it is based on some vacuum method, electromagnetic pump, so which will fill the cavity. Similar to the other process, it will avoid any you know that oxide formations. So this turbulence will be avoided in this. Then we have so that is regarding the low pressure die castings. So now we have squeeze castings. So squeezing. So in this casting is obtained by using the squeezing action. So one thing is, I'll show the diagram here as well, so you'll get one idea. So this is how squeeze casting occurs. So initially, so if you see the second diagram, we pour the molten metal into the die. Then we use then we use the other die, the male die, in, just to fill it. Then we apply some pressure on it using this hydraulic press. Then we remove, so that whatever the metal that is poured previously, it will occupy the pattern on the female die. Okay, that is, so we are using two methods here. One is die casting we are using, then we are using forging. So that is how it comes. It is a die casting and closed die forging. Okay, so it will, so these are the different advantages of this. So then we have semi-solid metal working process. One is geocasting and thixoforming. So these frames of mobile, previous in past they used to come steel like metal frames. If you see the buttons with the buttons, so we used to have that frame. So that is how we get using this geocasting or thixoforming. These are the two methods. So these are the semi-solid process in which we create the we get the pattern using some external force. So one is melt agitation, or we use impellers to mix the metal when it is in semi-solid state. It is not completely liquid or not completely solid. So we work in this between solidus and liquidus range. Okay, so it will avoid the formation of dendritic structures. So these are the parameters that we use in geocasting. Where comes the thixoforming? So some fluids which will thin on mixing, shear when material, but thicken when standing. Okay, this is similar to the corn flour liquid. So which is when stationary, it will never flow, but when you mix it, due to the shear induced into the melt, it will flow. It will have that property to flow. So this is what I'm discussing. It is, we are working in solidus and liquid dust temperature. So that range is what we are working. So these are the different types: MHD casting, strain induced melt activation, or spray casting. These are the different types of these sticks of forming. So these are some more special casting process that we are discussing. So then comes the other casting process, that is centrifugal castings, followed by the investment casting. So these are the main two other special casting process. So this is pretty simple. That is, we are using this centrifugal force in this in order to create the casting parts. Okay, so I will show the diagram itself. It will be easier. So this is what centrifugal casting looks like. So if you see in the side view here, so when you pour the metal inside, this mold will be rotating completely. That is visible in the end view. So when you pour the metal, it will since due to the centrifugal force, it will form a thick some small thickness around the shell. Okay, and finally we obtain a hollow tubes. So we generally get these caster and pipes that are are mainly made of these centrifugal castings. Okay, so molten metal is poured in the revolving mold and allowed to solidify pressure of centrifugal force employed for mass production, and it will have very high densities because of this uh, centrifugal action, promote directional solidification, good surface finish. Casting produces are free from impurities. So these slags, oxide, everything will get separated and they will be calculated at the center due to that centrifugal action. Okay. So this is the 300 to 3000 RPM generally we use. So we have different types: true, semi, and centrifuging casting. Okay, centrifuging. In true centrifugal casting, this is what I showed here. This is the true centrifugal casting. In semi-centrifugal casting, so generally this is the part. So we in this we'll have a sprue. Okay, this is kind of sprue in which we pour the metal and we rotate the complete structure, so that we get these types of figures, these types of component. This is the semi-centrifugal casting, and this is the centrifuging casting. Okay, it will also have a center sprue, and so it will have that centrifuging action. So if you know, this comes from the centrifuging machine that generally we use in to separate the chemicals. Okay, so that is all about the centrifugal castings, and it has its own advantages as well as disadvantages. Okay, and every you see, if any casting process is happening, so we have to keep in mind what is the yield that we are getting in it, whether the yield is getting minimized, and what is its significance. So in this we can easily produce axisymmetric parts as well as this type of different structures with ease, which will be difficult if you are using pressure die casting or permanent mold casting or sand castings. So that is what this centrifugal casting is different from the other casting. So in that way we can remember this type of castings. So now comes one important special casting, that is the investment casting. It is also called precision casting. It is also called lost wax casting. Okay, so I will explain with this figure. So initially, so this is the component which is made of wax. That is, using wax injection will make the pattern, and this will be attached to a central sprue. So this is the central sprue. Then we use this. We use a ceramic. This is the ceramic bath in which we dip this multiple times till we get certain thickness. Okay. Then we heat it in a furnace completely, so that the wax is completely removed. That is nothing but de-wax. Okay. Then using gravity we pour the molten metal inside. Then we break the mold at the knockoff. Then we cut out the component from the sprue. Then we finish the casting. So this is the investment casting. You see there were several steps in it, but still it is work, and the surface finish that we get is very high in this, and we can produce very intricate shapes as well. So even we can produce these turbine blades with these investment castings, and we can at one go we are getting good number of castings, but still there are several steps involved in this. That is the main like thing in investment casting. Okay, let us see advantages. So complex shape and thin section can be produced with good dimensional accuracy. There will be no parting line, no or little additional machining, and wax can be reused. The disadvantage is this expensive process. Still, as I discussed earlier, so there were several number of steps that are involved in this. So this is the main application, that is producing the turbine blades or pinion gears, etc. using this investment casting. Then comes continuous casting. So this is the continuous casting method. So in this we can directly produce slabs. So we can see here slabs. So we completely melt the molten metal, then we pour into the turn dish, followed by will be a copper mold in which this molten metal enters. So since copper is very high thermal conductor, so it will easily form a thick shell on the solidified metal. Still there will be liquid inside, but the outer face will get the thickness which is enough to bear the inside metal. So when it is traveling with the help of rollers, it will be cooled using these spray coolings. Then we get finally these slabs, and finally the slabs are cut off. So this is very continuous casting. The yield is very high in this process. If you see, there is nothing is going waste, everything is getting utilized. There is no gating system, nothing at all. Very less uh, wastage is going, very high yield we can produce in this continuous casting. So here we are getting 100% casting yield. The process can be mechanized completely. Labor cost is less, casting results are better, grains and structure can be easily controlled. So we generally use this for brass, bronze, zinc, copper, aluminum, and its alloys. So generally we use for blooms, billets, slabs, sheets, copper bars, etc. Okay. So these are the different types of special casting process. So next topic will be on furnace. Before going to this, I will discuss some of the uh, questions regarding this week. Then I will go to this lecture. If there is any question, you can ask in between as well. Okay. So this is the first question. I will give some 1-2 minutes to discuss. Then I will answer the question. So spend some time, 2-3 minutes on this. Then I will answer the question. Okay, let me read. So, which of the following studies are correct for hot chamber die castings? So, molten metal is brought from separated holding furnace to be injected into the die casting. No, in hot chamber die casting, the complete setup is inside the furnace. So, there is no need for bringing it from a separate holding furnace. So, one is the correct, one is the wrong statement. So, generally, these casting machines are suitable for low melting and low point alloys like zinc or lead. Yeah, this is the correct statement. So, two is the correct in this case. So let us move to the next question. Okay. So let me read. So which are the following statements are correct for? This is regarding this cold chamber die casting. So molten metal is contained in separate holding furnace. That is true. The cold chamber machine is ideal for metals such as aluminum alloys. Yeah, this is also true. So pressure in cold chamber die machines ranges from 300 to 600 kg per centimeter square. So this was not discussed, but this statement is also true. Since I so in hot chamber we go till 150 kg per meter square, but in cold chamber die casting we go up to 3000 kg per centimeter square. So this statement is also true in this case. Okay. So option B is the correct one. You can use for aluminum alloys as well for cold chamber die castings. Okay. Let's move to the next. Okay. So let me discuss. So which of the following statement is the correct for? This is regarding die casting. So first thing is productivity is high in die casting. That is true. Close dimension control can be maintained. That is also true. There is no limitation on size of the casting today. So this is not correct because we have a limitation. That is, we can go only till some 10 kg castings. So we have a size limitation in this die casting process. So option 3 is wrong. So C is the correct one in this case. Okay, let's move to the next question. Yeah, this is straightforward question regarding this squeeze casting. So it incorporates the advantages of forging into the casting process. That is true. Pressure is applied by hydraulic ram till the solidification is complete. That is true. The advantage of applying pressure is to remove the gas or shrinkage porosity. So you will be correct. So if you remember squeeze casting, so we took like this. So initially we fill till here. Then we use the upper die with force. So finally we got this type of casting. Okay. So let's see the other question. So this is regarding centrifugal casting. Okay. So option D is the correct for this fourth question. So for this fifth question, so which is regarding centrifugal casting, molten metal is poured into metals while the later are revolving. Correct. The impurities being lighter in weight are left behind in the periphery. So this is the wrong statement. So these light metals are collected at the center. Okay. This is the casting. So this is the refractory. So when it is rotating, these lighter metals will get collected at the center, not on the periphery. So this is the wrong statement. So A is the only option correct. These impurities can be anything like slag also. Okay. Let us move to the next question. Sorry. Okay. So this is regarding centrifuging casting. So as we saw earlier, so there will be different number of casting with the central screw. Okay. Okay. So mold cavities are symmetrically arranged of the axis of rotation around a central screw, which is correct. This central screw feeds the metal into the cavities through a number of radial gates. So these are radial gates. So both statements are correct in this case. Okay, let me. So if, so this is regarding centrifuge casting. So we have different types in centrifugal. One is true centrifugal, semi-centrifugal. Then this is the centrifuging casting. Okay. So this question is regarding investment casting. Okay. So first thing is it uses clay as binder to form the mold. Correct. The patterns are generally prepared by injecting the suitable grade of wax composition into a metal die. Yeah, this is also correct. No, this statement is wrong. The first statement is wrong because we are not using any clay. We are using some ceramic bath or ceramic slurry followed by stucco coating. Stucco coating. Some coating will be there. So we are not using. So option one is wrong. Only is the correct statement. Okay. So this is regarding continuous casting process. So this question is regarding continuous casting. So in which we use copper mold. Okay. Okay. So this is regarding so first thing is it involves continuously pouring metal into rapidly cooled reciprocating molds. So but still we are using sort of stationary copper mold here. Okay, we will see that. Then it is used for manufacturing blooms and billets. Yeah, that is the correct statement. So generally, this copper mold is. Give me a minute. I think the first statement looks correct. So in some cases, we can use reciprocate modes as well. Okay. So generally we can say that they are like oscillating. Means there are different types. So this statement will stand based on these oscillating modes. Okay. So both options will be correct. So we have different continuous casting process in which one we can use stationary mold, other is oscillating, nothing but reciprocating mold. So based on the second type of method, this option stands correct. Okay. Okay then. So now I will discuss the other part of this session. Okay. So so these are regarding the furnaces, like technology of melting, types of furnaces. So I'm using Professor slides for this as well. Just a minute. So yeah. Okay. So now, so furnaces. So this is regarding furnaces that we use for melting. Generally, this is to extract the metal from the ore. Okay. For example, from iron that we get from iron ore. So these are the in furnaces. The types of furnaces and the lining that are used inside are the two important elements in deciding production stuffs in foundry. So the factor in addition to these processes include metal temperature, metal delivery rate, and metal melting cost. So I will regarding these four things I will discuss one small for derivation in which we find the diameter of some one furnace. So these are the different types of furnaces. So first one is the crucible furnace, in which directly we take a crucible and heat the crucible with different types of elements. The other one is open heart furnace, then reverberatory furnace, rotary furnace, puller furnace, electric arc furnace, and induction furnace. Okay, let us read one by one. So first one is crucible furnace. So this is direct. It is this is of two kinds. One is coke fired, and the other one is oil or gas fired. So in coke fired, so which see if you see this red one, that is nothing but the coke before melting. So initially we fill this completing with the coke. We use a air blower. We start the this coke burning. So after some time we'll get this red hot thing. We directly place the crucible inside at the ladle inside and we melt the metal. Okay, we have a chimney for escape for these flue gases to escape. Yeah, sorry for this. Okay, so that is regarding this coke fired in which we are directly burning the coke itself. So when it comes to the oil gas fired, in this thing is replaced with the burner, in which we provide directly this fuel to the burner so that it will provide the necessary requirement heat to the crucible. Okay, these are the simple crucible furnace that we can easily use for small castings. Then comes open hearth furnace. So the main advantage in open hearth furnace is that so whatever the flue gases that are coming out, they can be used. So this is the charging in which we keep whatever the iron ore or whatever the things that we'll keep inside. Then once we burn the coal, everything, then these flue gases will be you know will be sent out. So they are coming again. If you see this part, and they will heat the gas that are going inside. Okay, so that is not only a regeneration that we are going to use in this case. So that is how these flue gases will heat the gas that incoming gases, so that the efficiency of this burning of this process will be good. So that is regarding this open hearth furnace. Then comes the reverberatory furnace. So this is the charge that whatever we want to heat, and these are the flue escapes. We will have a gate here in which we directly put the coal and whatever, and we'll just burn it. So we'll burn it so much that the flue gases will be very high temperature. That flue gases will heat during with conduction, radiation, everything will heat the charge itself, and they will escape. So that is what this reverberatory furnace is. Then comes the famous Kupla furnace that we use for getting these iron melting units. So here, if you see, so we have this will call two tire, this door, the charging door. Then we have alternate layers of coke, iron, and limestone. Okay, alternate. So if this is the coke, then iron ore, then limestone, then coke, iron ore, limestone, in that sequence. So there will be alternate layers. Then there will be a working door. There will be a slag. So this is the two tire. Sorry, this is the two tire. Then we'll directly get the molten ore, molten metal at the tap hole. We directly tap it. There will be one hole for slag removal itself. So this is a continuous process. We can continually charge this coke, iron, limestone, and we can continually get this molten iron. Okay, this is the simple cupola furnace.
Then we got this cokeless cupola furnace, in which we replace these alternate layers with a refractory bed. If you see these big circles, white circles, that is the layer of this. Instead of we are keeping this limestone coke, we just keep refractory bed. Then we keep the charge on the top and we heat it from the bottom. So that at the end we get from the left we'll get slag and from right we get the iron tap hole. So what is the need for coming this cupola furnace to cokeless cupola is that yeah, I think there is so much of wind. So the main advantage in this cokeless cupola is that the flue gases in this cupola furnace contains this SO2, which are not good for the environment. So that is the reason, main reason to replace that cupola furnace with cokeless cupola furnace, in which we directly use this burners, okay, combustion chamber or burner with fuel. Okay, then comes the famous electric arc furnace used for melting. This is for small batches, not continuous, but this is the continuous. So in this, uh, we use the principle of resistance between the uh, these plates as well as the electrodes. So they generate a arc which has enough potential to melt the scrap metal itself. So in this we have to take care that this will not damage the lining. So this refractory lining. So if this arc touches the lining, it will get damaged. So that is the main thing we have to keep in mind while designing this electric arc furnace itself. Okay. And in this electric arc furnace, we can go up to very good high temperatures. So in the same way, we have indirect electric arc in which will not heat the molten metal, but instead we heat the charging door itself. So we have a charging door, and we'll keep these electrodes, and it will generate enough heat uh, so that you, with the help of convection or radiation, the metal will get melted. Then we have this induction furnace mainly used for iron. So this is based on eddy currents. So when so these are the copper coils. If you see copper induction coils, so this will carry current, which will induce eddy currents in the workpiece, which will create heat, which is enough to melt the molten metal. This is mainly used for iron, which is and this is to be used for metals which is having high magnetic permeability. If magnetic permeability is less, it is very difficult to heat the metal. For example, aluminium. So it doesn't have a good magnetic permeability for aluminium, so we cannot heat aluminum using induction coils. Whereas iron has a good magnetic permeability, we can directly heat it. We have two different types in this, core and coreless. This is the coreless induction furnace, and this is core type. So in which we will use a core. So this is the core, the bottom part. The principle remains the same. Okay. So this is regarding these furnaces. So I will just discuss one small designing aspects. Then we'll go back to the revision. Okay. So this is derivation is regarding how to find the diameter. So let me discuss this. So we have, so initially we let us assume some items. So first thing is, so we need approximately 8.4 meter cube of air per kg of ore. Okay. So these are the parameters that we need. So we generally need 8.4 meter cube of air per kg of core. And we have metal to coke ratio. This is around 6 is to 1. That is, for every 6 kgs, I need 1 kg of coke to 12 is to 1. These are the ratios. So then we have plan area. So this is like the area that we require to melt these things. So 14 centimeter square. This is for kupla. Okay. For delivering 1 kg per hour of the metal. Okay. So these are the requirements. So now, for example, suppose if I need to design a cupola furnace for around 5 ton per hour. Okay, this is the metal requirement or the delivery requirement. Okay, so now I have to see, they have given us, this is the one thing they have given, then they have given, so 8 is to 1 is the metal to coke ratio. Okay, so from these two items, coke required is 1 by 8 into 5 tons, that is 5000. So this will give you 625 kg. Okay, so in this we need 625 kgs of coke for every 1 kg, sorry, for every into multiplied by 8. Okay, that is nothing but 5 tons per hour. So now, so the plan area required. So here I give 14 centimeters for delivering 1 kg per hour. Okay, but here uh, we are delivering 625 kgs. So we simply multiply 625 into 14 centimeters square.
which will give me 8740 centimeter square. So this is the plan area. So this is the given items. So from this we calculated the coke requirement, that is 625 kgs. From coke requirement we calculated the plan area. So now we have to calculate the diameter of cupola, that is this diameter. So this square is 8740, from which we calculate. So we get around 106 centimeter. It is nothing but around 1.06 meter of diameter for 5 tons per hour delivery rate. Okay, this is the simple designing for this cupola furnace.
Yeah. Okay. So, which of the following statement is are correct? The first one is efficiency of oil-fired furnace is more compared to the coke-fired furnace. The second one is open hearth furnace is used to produce steel from pig iron. Yeah. this is the correct statement. Second one is, as well as the first one is the correct. So we, sorry for that. Yeah. Actually, since the, if you compare with oil or coke, the fun efficiency of the oil fired furnace is more compared to the coke fired furnaces. So both statements are true in this case. Okay. So let us go to the next question as well. So this is regarding electric arc furnace. So I have already showed earlier. So basically in electric arc furnace, okay. So we can have multiple electrodes, not only single electrode. We can have multiple electrodes. So there will be a generation of arc between them. So which is enough to melt the molten metal. So the first option is steel scrap is heated and melted by heat of electric cars striking between the furnaces and electrode. So this is furnace. Okay. So which is the correct statement? That high melting temperature and faster melting rate can be achieved, which is also correct in this case. So this is also true in case of this second statement is also true in case of induction furnace. So in which we have crucible made of some conductor or any metal. Even inside also we can have any metal in that case, or else we can use iron. So the reason behind is we have to have higher magnetic permeability. So that is the only requirement in this case. Then we have this windings. So this will generate some eddy currents in the this workpiece or the charge, which is enough to melt the metal inside it. So this is also higher melting temperatures and faster melting rate can be achieved in this induction furnace as well as this electric arc furnace. Okay. So any doubts? So if there are any doubts, we can discuss. So this is the last question. So this is some of the numerical theoretical questions that can be uh, discussed, which can be useful for the solving these assignments. So the principle in this induction furnace is where I is the current, R is the resistance, and T is the time period. So that is the Q, kilojoules. Okay. So if there are any doubts, I would be happy to discuss. So as I discussed earlier, in this cupola furnace, so these alloying elements. So I will name some of those alloying elements. Carbon, then silicon, then we have manganese, then we have sulfur. Okay, so carbon will increase since the coke is directly in contact with the iron. Then silica will get decreased. So we have to add supplement for this. Similarly, magnesium. This sulfur, we have to see this low content is present. Okay, so that it will not deteriorate the mechanical properties of this iron. Then we have phosphorus. Similarly, we have to reduce this phosphorus content. Then finally, we have this ferrous. Okay, suppose if you are using for any non-ferrous casting, so these are the some of the alloying elements that usually be in the this cupola operations. Then we need to take care of some of the parameters we'll discuss. So the first parameter among them is coke rate, which is as I discussed, for every 8 kgs of ore, at least 1 kg of coke is required. This is the coke rate. Then the second one is blast rate. So at what rate you're using this blast, so that the combustion process is controlled in that case. So this blast rate will be around 7 to 70 to 125 cubic meter of air. Okay, per square meter of cupola. Okay, cupola, COPOLA. Okay, so we need around 70 cubic meter, 7 meter cube of air per 1 square meter of cupola. Okay, this is the blast rate. So then we have one more parameter, that is the coke size. So generally this size should be 50 to 75 mm. This is along with the charge. In the bed, so we have a coke bed, in that it should be 125 to 150 mm. So these are the parameters that need to be foreseen in cupola furnace design. And here we have discussed how to design this cupola furnace. So basically we need how much of meters, this is also centimeter cube, how much of meter cube of air per kg is needed, one thing. The second thing is what is the ratio of metal to coke ratio. Then we need, so this plane area is fixed, that is 40 centimeters square for delivering 1 kg per hour. This 1 kg is nothing for the coke. So for example, so we discussed if there is a requirement of 5 ton per hour and the coke ratio is 8 is to 1, so we can use 1 by 8 of this is the coke, that is 625 kgs, which is burning per hour. So if we multiply this with this factor, so we get 874 square meters of plane area. And if we equate this to this formula, we'll get around 1.06 meter. So for 5 ton per hour ore, we need, not ore, this is metal, we need 1.96 meters of cupola. So that is how we generally deal with this. Okay. If there are any questions, we can discuss, or else we can end the session itself. Yeah, just I'll just go through the questions on a brief way. So the first question is regarding hard chamber die casting. So in which we will use direct, the furnace complete setup will be inside the crucible. So there will be no use of separated holding furnace. The second question that is regarding the cold chamber die casting. So in this, we use a separate holding furnace, and this is for melting some small low melting metals such as aluminum, zinc, magnesium. Then here we use higher pressure when compared to the hot chamber die casting process. Then we have the advantages and disadvantages of die casting. The productivity is high, correct. Close dimension can be obtained, that is also correct. But there is size limitations in die casting. So the maximum size you can go till 10 kgs of the casting. Then comes the squeeze casting. So it is a combination of casting and forging, in which this is also kind of hybrid semi-solid processing. So as I have shown in the diagram, so initially we will fill the die with the liquid metal, then we use a punch. Then we use hydraulic press to punch it even further so that any gas or shrinkage processes are present, they can be eliminated. So in centrifuge casting, if there are any lighter metals or impurities, it has very low density, so they will be collected at the center. So that is one advantage in centrifuge casting, and we can get very high density at the periphery. Then in centrifugal casting, we have different types of centrifugal casting. One is true centrifugal, then semi-centrifugal, then this is centrifuging centrifugal casting. So in which we'll have a central screw and we'll have a radial gates as I shown here, and and these are used for symmetrically arranged cavities. Then in investment casting, we will not use any clay type of uh, binder. We'll directly dip in ceramic slurry. We'll have a multiple ceramic coatings till we get desired thickness. Then we burn out the wax. So that is we also call as stucco coating. Okay. So in continuous casting, so we have different types of continuous casting. So in which we can use a stationary die, a stationary mold, or we can use oscillating mold or reverberating mold. Then we have questions regarding these furnaces. The first statement is true because oil have little more efficiency when compared with the coke fire. Then in open hearth furnace, it is used to produce steel from pig iron, which is the true statement. And the advantage in open hearth is we use the flue gases to heat the air, incoming air. So that is how we increase the temperature of incoming air. So which will finally improve the efficiency of the process. Then finally we have this things regarding the electric furnace. Okay, okay. So if you have any doubts, you can ask or we can close the session. Okay then. So we can close the session. Thanks for attending.